Algebra 2 students of mine, and anybody else listening to this amazing video. Okay, it's not amazing, but it is math. And we do have Brugger's coffee. Although, I haven't made a dime off Brugger's coffee yet. But I'm still enjoying it. Congratulations to Hilton High School's boys soccer team last night. Western New York Regional AA champs. Oh yeah, it was a late night. Gotta go weekend. This weekend we're going off to some other place. I have no idea where it is, but it's far away. By the way, if you're here watching my videos, could you do me a favor? Hit the subscribe button. I could use a few more subscribership. If you'd like to, you could donate. Still trying to look to get a new computer. You know how much has been donated so far? Almost nothing. But I'm still open. Brugger's coming through. Just kidding. Here we go. All right, guys. We're going to talk about the focus directrix form and how we can create a parabola using the directrix and the focus. What is a directrix and focus, you ask? I'm not going to tell you just yet. Just wait. First things first, a little warm-up. Let's go through the warm-up. Describe the locus of points equal distance from, well, in this case, 5 units from a point. Well, let's plot that point. 0, 2. 0, 2. And if you had to go 5 units away from that point, you could go 5 units up. 1, 2, 3, 4, 5. You can go 5 units to the left. 1, 2, 3, 4, 5. You can go 5 units down. 1, 2, 3, 4, 5. You can go 5 units to the right. 1, 2, 3, 4, 5. Wait, no. 1, 2, 3, 4, 5. And if I kept going and going and going, eventually I would create this thing we like to call, you guessed it, a circle. Now, I'm sure you guys were pretty excited about the fact you weren't going to have to discuss locus to point again. But the locus of points, 5 units from a point, is a circle with a radius of 5. So it has a center of 0, 2, and a radius of 5. Well, then we know how to write that formula. Remember, that's our formula. X minus h squared plus y minus k squared equals radius squared. Well, since the x part of the center is just 0, this is just x squared plus y minus 2, goes in backwards, squared, equals 25. And that's the equation of that line. All right, wow, why did I bring up this thing called locus? Oh, look at this. The locus definition of a parabola. So, a parabola is a, yes, it is a locus of points equidistant I probably should have just said equidistant from a fixed point known as the anybody focus your energy. Oh, that's what it's called. It's called the focus. And a fixed line known as the Directrix. Focus and directrix. And that's what we're doing today. We're doing the focus directrix form of a line. I did talk about that, didn't I? Didn't I call this a focus? Right here, focus and directrix form. All right, here we go. What are we going to do? So, on the set of axes below, graph the locus of points that are equal distance from the point 0, 2 and the x-axis. Whoa, it's a little bit different. So here's the point 0, 2, and here's the x-axis. It's hard to me to do in red. So I need all the points that are equal distance from a line and a point. Well, let me do those in blue. Would you agree that point is equal distance? How about this one? and this one. And if I went over, let's say 1, 2, 3, and up. Well, what it turns out to be is, let me go 1, 2, 3, 1, 2, 3. Yeah, the other one is going to be, and it has to do with Pythagorean triples. The other one is going to be going up 3, 1, 2, 3, 1, 2, 3, 4. So if I go up 3 and over 4, then you guys should know that the distance from here to here is, you guessed it, 5. And if I go down this distance here, it's also 5. And so I'll do that same thing, go up 3 and over 1, 2, 3, 4. 4. There it is. And so what you'll see here is, and I'll draw this in, let's go our green, is it'll end up being all of these points. Well, look at that. All of those points creates a parabola. This is called the focus, and this is called the directrix. Directrix. I wonder how many times I'm going to misspell that in class. So how far is the vertex? Oh, wait, vertex. Ooh, there it is. That's the vertex from the focus and the directrix. Well, in this case, it's 1 unit away. Crack my things. Not only is it 1 unit, but it's also equidistant. Equidistant from both the focus and the directrix. All right. So what we're going to do now, and here's the tricky part, we're going to use our distance formula to show that this point 4, 5 is the same distance away from the focus and the directrix. And that was this point we picked up here. 4, 1, 2, 3, 4, 5. 1, 2, 3. Oh yeah, 4, 5. Oh my gosh! For some reason, in my brain, I was thinking 5, 4, 5, 4. No, 5, 4, 5, 4, 5. The point 4, 5. Perfect. All right. So if you remember the distance formula, the distance formula is equal to the square root of the change in x's squared plus the change in y's squared. I don't need to write minus. You got it. So let's do from the point 4, 5 to the line y equals 0. Line y equals 0. Well, this is just the x-axis, right? Well, that's easy. I'm just going to count, right? What is the distance from here to here? Don't you just take the y value, which is 5, and subtract off this? So you just get 5. Then I want to find the distance from the focus, which the focus in this case is the point 0, 2, and the point that we said was equal distance, 4, 5. I want to find that distance. So we're going to use the distance formula. The change in the x values is 4. We'll square that. Plus the change in the y values, which is 3, and then we'll square that. This turns out to be the square root of 25, which of course is just 5. Therefore, they are equidistant. All right, what are we doing here? Derive the analytic equation of the parabola given the focus 0, 4 and the directrix y equals 2. So here's our point 0, 4. And here is the directrix y equals 2. Now, we also see that the vertex is the point 0, 3. Now, having learned what I taught you before, never mind. I don't want to get into that right now. We did part A. Don't know where my... Label the point XY anywhere on the graph. And it really makes no difference where you label it. I need to find a nice one. Let's call this point right here. We'll use this point. I want to use the same one I used in my example. So we'll use this point right here. We'll use that point. And that point is the point 1, 2, 1, 2, 3, 4. So 2, 4. We're going to use that point. And so what we need to do, we got it, is write an expression for the distance from XY to the directrix. So I want to find the distance. In this case, the distance is equal to... Oh, wait, I want to write an expression, so I don't really actually want to calculate something. So this should work for any point. If I pick this point, or I pick this point, or I pick any point. If I pick any point in between, even this obnoxious point right here. This point right here is x comma y, correct? Now in this case, I gave an exact example. I said label it xy. I should have called this just x comma y. So to find that distance, we take the y value of whatever point I give you, in this case xy, this y value here. And how do I find the distance? Well, I'm actually just going to count, or I'm going to, this y value is the distance from here to here. Well, this distance is all that except for this 2. So we're just going to subtract off the 2. Does that make sense? Let me clear the graph just a little bit. Make sure you understand what I'm talking about. Oh, crap. Control Z. Went too much. Okay. So let's take a look at this again. The distance from here to here is y, right? Because you count up y units. The distance from here to here is 2 because this line is y equals 2. So this part that remains, which is this part right here, is just y minus 2. So that distance is y minus 2. Now I want to write an expression for the distance from the point xy to the focus, which is this thing right here. So really what we're going is from xy to the focus, which is 0, 4. Okay, so we're going to use our distance formula. Our distance formula takes the square root of the difference of the x's, which is x minus 0 squared, which is just x squared, plus the difference of the y's, which is y minus 4 squared. Well, this is just really equal to the square root of x squared plus y minus 4 squared. All right. Come on, move. So apply the definition of a parabola to create an equation in terms of x and y and solve the equation for y. So what did we say the definition of a parabola was? Our definition of a parabola is a locus of points equal distance. That means that the distances have to be equal to each other. In order for it to work, the distances have to be equal to each other. So I have two formulas. I have this formula right here, which is the distance from the point that we were given to the directrix. And I have this equation here, which is the distance from the point that we got to the focus. Well, those two things, if this is a parabola, have to be equal distance, or they have to be equal to each other. So all we're going to do is set them equal to each other. So y minus 2 is equal to the square root of x squared plus y minus 4 squared. All right. So now we have to solve. We have to solve this equation for y. Now you'll notice there's a y here and a y here. So for all of you that are just going to add 2 and say, oh, look, I solved. I don't think so, kids. We got a lot of work to do on this one. So what we're going to do is we're going to first get rid of that radical. And we're going to do that by squaring both sides. So hopefully you don't stress too much about this right side. It's just y squared minus 4y plus 4. Now remember, you're writing it twice and double distributing. Is equal to x squared plus, wait a second, oh, y minus 4 squared. But maybe I don't like that y minus 4 squared, because I really know that y minus 4 squared is really y minus 4 times y minus 4. So that is just y squared minus 8y plus 16. All right, now the equations solve for y. Solve for y. Well, the cool thing is these things go. That's nice. And I just have to get the y's together and everything else together. So let's see. If I add 8y, that'll come over here. I get 4y is equal to, subtract 4. So this is gone, subtract 4. I get 4y is equal to x squared minus, plus 12. Well, come over here. I got to get rid of that 4. What I have right now is 4y is equal to x squared plus 12. Now what I'm going to do is divide by 4. And I'll finish the problem off. So I get y squared is equal to 1/4 x squared plus 3. Now this is just a parabola that has moved up 3 units and is dilated and made wider by 1/4. So do I have a parabola that used to be here that went up 3 units? Oh yeah, there it is. There it is. And is it wider? Well, let's take a look at it. Does it look wider to you? Yeah, did we go over 1? And nope, we went over 4. We went over 2 and up 1. We should have gone over 2 and up 4. Well, that's 1/4 as much. So there it is. That's how you do it. Alrighty. What is the transformation from, there we go. To go from this, oh, by the way, this should not be y squared. Why do I have y squared? It's just y. It's just plain old y. To go from this to this, the only thing is that, let's see, it's the same dilation. All we're doing is it's a translation down 1. You guys know that, right? Translation down 1. Alrighty, moving on. What's going on in the next line? So this kind of gives you an idea of what's going on. This point here is called the focus. And, let's come back to it. We got the vertex. We know what the vertex is. The vertex is the point where the axis of symmetry. Well, maybe I should start with the axis of symmetry. The axis of symmetry is the equation of the line perpendicular to the directrix and passes through the focus and the vertex. Well, the vertex is where the axis of symmetry intersects the parabola. And we also call it the turning point. It's where it's turned up and down. All right, the focus and directrix, the point and the line that all points of the parabola are equal distance from, right? So it doesn't matter where you pick, right? These points will be equal distance, these distances. I could pick any point. I can pick this point right here and go here and here. Remember, right? You got to go 90 degrees. These things will be equal to each other. So if I come down here and I say, okay, here's my focus, here's my directrix, and I want you to just draw a few lines in. I'll use black. I could pick any point. I could pick this point right here. I thought I picked black. I can pick this point right here, and if I draw in the focus, or that line and that line, these two lines have to be equal. I can do this point right here. Equal. I can pick this point over here. It doesn't matter what point I pick on the parabola, these will be equal. And the same thing holds true for here. Let's say I pick this point right here. If I draw that distance in and that distance in, they have to be equal if it's a parabola. And of course the vertex, right? Equal distance here and equal distance here. That one's easy. Pick one point way out here. Of course, equal distance. All right. Let's just do a little more practice. We're going to use the distance formula to find the indicated distances between these 2 points. So let's do this in red. So we're going to use the distance formula. The distance is equal to the square root of, we're going to, what is the change in the x's? 4 to 0. Well, that's just 4 squared. Plus, what's the change in the y's? 2 to 1. Well, that's just 1 squared. So the distance here is the square root of 16 plus 1, which is just the square root of 17. Now I want to find the distance between the points, this point, and the line y equals 5. Well, how in the world am I going to do that? Sometimes it might be in your best interest to, I don't know where I went. What would it look like if I graphed this? Negative 1, 3. 1, 2, 3. That's right about there. And where's this line? Y equals 5. Isn't that this line? You see, I don't need a new computer, my goodness. Boom, kajoom. This is the line y equals 5 right here, right? So remember, the distance is as short as you can go. It's just this distance. Well, it's just the difference of the y's. So the distance is equal to 5 minus 3, which in this case is 2. All we're going to do is subtract the y values, and we get that, in this case, which is 2. All right, ready to get to work. Let's get to work. We've talked about it long enough. So what we're going to do is, for this parabola, y equals 1/2 x squared minus 2x, find the coordinates of 3 points. No, find the points. Why did I say 3 points? Of the 3 points on the graph whose x values are -2 and 0. Well, we're just going to do 2 points. I don't know why I put 3 points there. That's weird. I think I'm going to have to change that for next week. So we're going to plug in the x values of -2 and 0. All right, so y equals 1/2 -2 squared minus 2 times, for some reason I thought I did a different problem, minus 2. All right, so this is 1/2 times 4 plus 4. Well, half of 4 is 2, so this is 2 plus 4, which is 6. So this gives me the point -2, 6. And we're going to do 0. So y equals 1/2 0 squared minus 2 times 0, and I get 0, 0. There's the points. Show that the points in part A is equal distance from this point and the line y equals so what we're trying to do is see that these are the focus and the directrix. Directrix. So we got a little work to do. So what we're going to do, we'll do the easy one first. We're going to do it from the line here, because all I have to do for this one is subtract the y. So let's say we're going to work on the point -2 and 6. So all I have to do is subtract the y. So the distance is equal to 6 minus -5/2. In this case, since I'm going to have to have fractions anyway, yeah, we love fractions. This is 12/2 plus 5/2. I just converted the 6 to a 12/2, and I get 17/2. Okay, So what we want to do now is show that the point 0.02 or -2,6 is also 17 over 2 away from that. Well, this is a little bit trickier. The distance is equal to the square root of, now we got to do a change in y's. The change in y's are from -2 to 2. Well, how about this? -2 minus 2, maybe you don't see that's 4, squared, plus, now we're going to do the change in the y value. So I'm going to show you this work. It's 6 minus -3 over 2 squared. Oh my gosh, all this difficult work. You could just type this in your calculator. In fact, we're going to be using our calculator anyway. Might as well. But just to see if we can do it by hand, where am I going? I think here. Forgot a parenthesis. So this is equal to, well, this is just -4 squared, which is 16, plus, let's see, over 2, this would be, well, this squared, so this is really plus here. So 6 over, that's 12 over 2 minus, plus, excuse me, 3 over 2 is 15 over 2. If I had to add those, that would be 32 over 2 plus 15 over 2, which would be 47 over 2. I don't know. Whatever. Let's grab the calculator. Let's do the work. I done screwed something up there. I don't know what I did. So let's just do it. So let's do the square root of, I got my notes over here, 2 minus parentheses -2 parentheses squared plus the parentheses. What was the other one? Oh, I did. Well, whatever. I'll do it. I did it backwards here from what I did on my paperwork, but whatever. We'll do it. Control division. The point is, let me look at my notes. -3 halves. -3 over 2 minus the y value, which is 6 minus 6. Sorry. Squared. Come on, pen. Where'd you go? Take my mouse back out. Delete and squared. And it equals, look at that, 17 over 2. I don't know what I did on my math over here. We're going to pretend like I didn't make this math mistake. Oh. You know what I did? Just to go back, just to make sure you don't think I'm a moron. I forgot to square it. So if I do this squared, this is 225 over 4. So that means I got to do 64 over 4 plus 225 over 4, which is the square root of 289 over 4, which is 17 over 2. Over 2. Over 2. Over 2. And since they equal, then I know that this point is equal distance from this point. And equal distance to the line y equals. So now we're going to do the 0, 0. This one will be a little bit easier. So the simple one is distance is equal to 0 minus -5 over 2, which is just 5 over 2. And now we're going to use the distance formula. The distance formula is equal to 0 minus 2 squared plus 0 minus -3 over 2 squared. So this is equal to 4 plus, well, this just becomes 3 halves. 3 halves squared is 9 fourths. So this is equal to 16 over 4 plus 9 over 4. This turns out to be the square root of 25 over 4, which is equal to 5 halves. Now you could have, again, just done this on your calculator right here, but I see that I get that they're 5 away from each other. So the focus and the directrix of this parabola, the focus is this point right here, 2, -3 halves, and the directrix is y equals -5 over 2. Show that the point with coordinates x, y is equal distance from those 2 points. So here's how we're going to do it. What it's going to end up doing is, show that if the point with the coordinates of x, y is equal distance from both of these, then this is the equation of the line. I think I forgot to finish, but that this is then the graph or the parabola that describes any point x, y equal distance from these 2 points. Okay, so that's what we're going to do. So the first part is we're going to find the distance between the y values. We're going to do the easy one. So we're going to do y minus -5 over 2. So this is just y plus 5 halves. So that's the equal part. That's the easy part. The distance between the point and the directrix. That's the easy part. Oh, in my notes I didn't do that part. And then the other part's a little bit more complicated. It's going to be the distance between, so it's x minus 2 squared plus y minus -3 over 2 squared. All right. So this is just equal to the square root of, just clean it up a little bit, x minus 2 squared plus y plus 3 over 2 squared. And so if they are equal, we should end up with this parabola right here. If this is the parabola that describes all of the points x, y equal distance from this focus and this directrix, then we're going to turn out to be that parabola right there. Let's do some blue. So we got y plus 5 over 2 is equal to the square root of x minus 2 squared plus y plus 3 halves squared. Now, in order to save a little bit of space, because I'm going to run out of room, I think, on this page. Oh, it looks like I got plenty of room. What we're going to do is we're going to square both sides. Well, let me just write it, because I got the room. This is going to give me y plus 5 over 2 squared is equal to, now the square root and the square cancel each other, so this is just x minus 2 squared plus y plus 3 over 2 squared. Now we got a whole boatload of double distributing to do. Over here we're going to double distribute. I just said it. We got to need some more coffee. All right, so I'm going to kind of work through this one. This one's y times y, which is y squared. I'll show the work. Plus 5 over 2y plus 5 over 2y. That's the double distributing part, this part. Plus, and then 25 over 4, which is the 5 halves times 5 halves. This one's a little bit easier. It's x squared minus 2x plus 4. Remember, there's another x minus 2 right here. And then there's another y plus 3 halves right here. So this gives me plus y squared plus 3 halves y plus 3 halves y plus 9 over 4. All right, so let's start getting rid of stuff. I can get rid of the y squares. So I want to, let's just clean it up then. We've got 5 halves and 5 halves is 10 halves. 10 halves is 5y. So it's 5y plus 25 over 4 is equal to x squared minus 4x plus 6 over 2. Oh, wait, 6 over 2. That's 3. Let me get rid of that. That's 3y. Why can I not hit the eraser? So 6 over 2. When I combine these two, it's 6 over 2, which is just 3y, plus 9/4. All right, here we go. We're going to bring these two y's over, these 3y's over. It makes 2y over here, because we're going to subtract it, is equal to x squared minus 4x. Now, I got to subtract 25 over 4. So 9 over 4 minus 25 over 4 is equal to what? Sorry, kids, I made a tiny mistake. Let me go back because I'll show you where it is. I don't know if anybody saw it. It's right here. I forgot this 4. I forgot this 4 right here. So this side's a little bit messed up. So let me just clean up that side. Because I knew I wasn't going to end up with where I wanted to end up. And I'm like, what happened? I missed something. So let's try this again. So this gives me x squared minus 4x plus 4. That was the 4 I missed. Plus, remember, 3 over 2 and 3 over 2 is just 3. Plus 9 over 4. Well, maybe I don't like this 4. I have to make it something over 4. So how about 16 over 4? Because isn't 16 over 4 really 4? So what I end up with is 5y plus 25 over 4 is equal to x squared minus 4x plus 3y is plus 9 over 4. Excuse me. Plus 25 over 4. And where'd I get the 25 over 4? It's the 16 over 4 plus the 9 over 4. Okay, so now these match. So that's good. That's what I wanted. And I'm going to bring this 3y over. So when I subtract 3y, I get 2y is equal to x squared minus 2x. Divide by 2, and I get y equals 1/2 x squared minus x. Oops, this should be 4x. I'm trying to get out of myself. Oh! Like, I know where I'm going. I know what the final answer is. I just keep like, ugh. And now I can't find my mistake. All right, so right here. This should have been a 4x, right? Minus 4x. And when I divide by 2, I get 2x at the end. So there it is. Woo, man. Come on, Kraus. I don't know if I left enough room there for you. I might have to figure out if I can find some more room. There's not really no room on there. We're going to have to tell you to remind you to write small in class. So here we go. We're going to derive the analytic equation. We're going to create it. See, last time I gave it to you and said, prove it's equal to this. Well, what we're going to find is we want to find out what it is equal to. We're going to have something with an x squared here. We want to figure out what that equation's equal to. That's got equal distance from the point 0, 10 and has the directrix of the x-axis. Well, if you remember correctly, the x-axis is really the point y equals, or the line y equals 0. So we're going to pick any point. Any point. Well, that point would be x, comma, y. Any point. And we're going to find two distances. So we're going to find the distance, the easy distance first. It's just y minus the y value of the line. The distance between any point and that line is just y minus 0, which is just y. Well, I think this one's going to be not so bad. And then I want to find the distance between the point 0, 10 and the line y equals 0. Oh, no, 0, 10 and the point, we already did that, the point x, y. So, distance is equal to square root of, we're going to subtract the x's, so that would be 0. Let's start with x. I think it's easier if we start with x. So, let's do this. Sorry. What we're going to do now, let me get a different color. We're going to find the distance between the point 0, 10 and the point that we picked, x, comma, y. And I got lots of space. I was trying to clam it in just in that area and skip things, but I forgot I got all this space. So, x, comma, y. So, we're going to use the distance formula. And the distance formula says it's x minus the x value squared plus y minus the y value squared. Well, this is just equal to, I'll do it right here, equal to the square root of x squared plus y minus 10 squared. All right, so that's our distances. Now, if this is going to be if we're looking for that parabola that's going to have this as its focus and this as its directrix, all right, it's going to satisfy the fact that these two distances, if you satisfy the equation of our equation of the parabola says the distances have to be equal. Or in other words, y has to equal the square root of x squared minus, plus y minus 10 squared. So we're going to square both sides. This math's a lot easier than the last problem. You get y squared is equal to x squared plus. Now this one I'm going to double distribute out because I know I got to do it anyway. I might as well do it now. Y squared minus 10y minus 10y plus 100. All right, so my goal is to get y all by itself. Well, these y squareds cancel. So what I had, and then I've got negative 20y here, and that's negative, so I want to bring it over here. So I get 20y is equal to x squared plus 100. All right. Well, I still got to solve, so I'm going to divide by 20. And divide by 20. And divide by 20. So I get y equals 1/20 x squared plus 5. Nice big wide parabola. So what you'll notice is that what we had was the line, this was the line y equals 0, right? So this was our directrix. And that's the x-axis. And we had this point way up here, 0, 10. Well, in order for these points to be equal distance, first of all, we know the vertex is going to be 0, 5. It just is. But in order for them to be equal distance, this thing has to be a really wide parabola. So what you'll find out is the further away the directrix and the focus are, further this distance is from here to here, the wider the parabola. If I pick a parabola where the focus and the directrix are really close to each other, I get a much different looking parabola. Alrighty, well that's all she wrote. I was looking for my, I used to have a Java applet that could show you that depending on how far away you move the focus and directrix away from the focus away from the directrix made the parabola wider. But apparently Google Chrome is crashing on all Java applets right now. So, I'll try to find one that we can work in class if I find it. All right, kids, that's it. Focus and directrix, how to find a parabola. All right, good luck. May the force be with you, and study hard, kids. Study hard. Keep working hard. The world needs less losers and more go-getters. And hit the subscribe button if you haven't hit the subscribe button yet.